Hello everyone, welcome to video lectures on data mining and data warehousing, module 4 classification.
Yes, so here we'll just compare with the degree of impurity. Yes. Okay. Yes, so here what we find is node B. Compare. Okay, node B has. I guess we stopped there in the previous node N1, and node N2 we are calculating the Gini error and entropy. So 0.5, 0.3, 0.8 you get here. And you can just see here the Gini value remains the same. Entropy value is little reduced. Error value also is reduced. So which is better than our previously calculated node A. Right, so here when you compare attribute A with attribute B would be the better choice, and this we can say that this would be the best split. Okay, so with this error calculation is done. Okay, yes, let's continue with the rule, classification. Here we have already seen one type of classification, so that sorry for the disturbance. Okay, the next classification technique we have, that is rule based classification, and we have already seen one of the classification technique, that is Hunt's algorithm, correct? Okay, the next classification technique is rule based classifier. Okay, we'll see what is this rule based. Yes, we'll take an example and then we'll see what is rule. Okay. Yes. Yes, here are the examples of few rules. Okay, how did we write these rules? For that, we'll just see the data set. Okay, we have this data set. I guess I had shown this particular data set. We call this as vertebrate data set. Yes, you can see several records here. Yes, and here you can just see we will take this as two class groups. Okay, the last column is class label, mammals and non-mammals, right? Okay, and you have several features. Out of these several features, we'll pick up few features which clearly says us, which clearly helps us in classifying the creatures into mammals and non-mammals group. Okay, just see which feature is of important. First one, body temperature. This looks important. This looks as though it's important. Okay, we'll see the other one also. Gives birth also is an important feature. With the help of these two features, can I classify the creatures into the mammals and non-mammals? Yes, I can write one rule, something like this. If body temperature of the creature is warm-blooded and if it gives birth, that is gives birth is equal to yes, then I can say that the creature belongs to mammals group. Just see whether this is true for other records as well. First record it is true. We'll see the other record where the body temperature is warm-blooded. Body temperature is warm-blooded. Gives birth is yes. Correct. It is clearly classifying it as mammal. Then again we'll go to warm-blooded and say warm-blooded and gives birth. Yes. Again it is saying that it is mammals. We got three records which says that my rule is true. Then again you come to warm-blooded, but here gives birth is no, and here it is non-mammal. Okay, I got one negative record. Why I'm calling this as negative? Because my rule is not satisfied here. It is saying that body temperature is warm-blooded, but gives birth is equal to no, so it is non-mammal, right? Okay, but this is negative. Okay, I don't have to see that. Again, you see here, this actually this is of no. I'm not interested. Why? Because here gives birth is equal to no, right? Okay, so here you come, warm-blooded is true, and then again gives birth is yes. Again it is saying that it is mammals. So till now I got three records. So 1, 2 and yeah, three records, third record, three records, which says that my rule is true. Okay, mammals. And then again you come to warm-blooded here. Here again, warm-blooded gives birth. No, it is saying that it is non-mammal. No, I'm not interested. Come to this. Warm-blooded gives birth is equal to yes. And again, it is saying that it is mammals. So total 4 records I have here, which says that warm-blooded and gives birth is equal to yes. And then if both the features are true, then it belongs to the class label mammal. So can I write such a rule? So I have here my rule set, in that the first rule says, where is it? Third rule says that gives birth is equal to yes, and body temperature. See here, the conjunction is and, right? And means both the conditions should be true. And body temperature is equal to warm-blooded. If both are true, then the class label, the creature can be classified as mammal. So you call this as if-then rule, right? So this rule is covering how many records, or this rule is satisfying how many records here? I got here around 4 records which satisfies this particular rule. Similarly, I can write some more rules here. What is it? See, some of the sample rules are written. Rule 1 says gives birth is equal to no, and aerial creature is equal to yes. If it's aerial creature and not giving birth, then it says that the class group, it belongs to birds group, right? So we can see whether there are such records. Gives birth no, and aerial creature yes. Gives birth no, yes. Aerial creature yes, it's classifying as bird. I got 1 record. Gives birth no, aerial creature no, still it is saying it's bird. It's a negative record actually, which says that it's bird. No, so I have only 1 record which says that gives birth is equal to no, and aerial creature is equal to yes, and it says that it is bird, belongs to bird. So here I have only 1 record for this rule 1, and again you can see for the other rules also. So you can see here all these rules might be covering or satisfying one or the other record here in this vertebrate data set. If I write a rule which doesn't cover any of the records here, for example, I write one rule something like this: gives birth is equal to no, gives birth is equal to yes, and aquatic creature is equal to also yes. Gives birth is equal to yes, and aquatic creature is equal to yes, or else I'll take one more, okay? Which is it? Aerial creature and aquatic creature both, if I take, okay, I can take, yes, I'll take here body temperature and aquatic creature. So body temperature is warm-blooded, and aquatic creature, let me take it as yes, okay? So warm-blooded and aquatic creature is equal to yes. If both are true, then I'll say that it belongs to the class group non-mammals. Let me see if I write such a rule, whether it covers any of the records in my data set. What is the rule saying? If body temperature is warm-blooded, and if aquatic creature, and if it is aquatic creature, that is aquatic creature is equal to yes, then it says that it is non-mammal. We'll see. Warm-blooded, aquatic creature is yes. Okay, it is saying that it is mammal. So I'm saying my rule is saying it is non-mammal, right? Warm-blooded, aquatic creature, no. Warm-blooded, semi, no. Okay, I don't have any of the record in the data set which says that body temperature is warm-blooded and aquatic creature is equal to yes, and then classify it as non-mammal. So that means what? My rule is a weak rule that is not covering any of the records here. Such rules I should not write actually, or you can say that such a rule has no zero accuracy, or it zero coverage, okay, right? So your rule should be in such a way that it should have high accuracy and high coverage. So what is this coverage and accuracy? Coverage, I just gave you the example, one such rule. What is the rule? Warm-blooded and gives birth is equal to yes. We have 4 records here which says that the rule is a strong rule, right? So these 4 number of records equal to 4 for that rule is actually the coverage of that particular rule, right? Accuracy, I'll just tell you how, to what extent your rule is accurate. We'll see how the computation is done, okay? Yes, so here we have taken the same example. Gives birth is equal to yes, and body temperature is equal to warm-blooded. Both are true, then a mammal. So this is one of the rule. We'll see the coverage factor. See, coverage, it is saying that it is 33% and accuracy is 100%. So how to calculate the coverage and accuracy? We just see. For coverage, I'll just show you the coverage. Okay, so the formula is not there over here. I'll just show you the formula to calculate the coverage. Okay. Okay, just see here the formula. Okay, the formula says that coverage can be calculated something like this. Okay, A divided by D. What is A and D? I'll just say. This is the rule. See, if I write a rule something like this. A is the left hand side of the rule. Y is the right hand side of the rule. So just now I have written a rule, and the rule is saying that the left hand side of the rule gives me the condition, right? So two conditions I have in my left hand side of the rule. Gives birth is equal to S and body temperature is equal to warm blooded. Now I just have to count the number of records in the data set which has this both of these conditions. Let's see the number of records which has that. A refers to the number of records, total number of A records to the left hand side of the rule. So that is a count of records which has that condition. So we'll go to that data set and see there. Oh, sorry, previous one. See this data set and count for the number of records which has the left hand side of the rule. So left hand side of the rule is gives birth is equal to S and body temperature is equal to warm blooded. So body temperature is equal to warm blooded, gives birth is equal to S. So count is 1, count is 2, count is 3, count is 4, count is 5. So total 5 records I have just to see the left hand side of the rule and count the number of records which has both the conditions true. So here I have 5 records in this data set which has this left hand side of the rule, or which has the condition in the left hand side of the rule that is satisfied, right? So total 5 records I have. That becomes my numerator. And what is the denominator saying? Denominator is something like, denominator is D. What is this D? D refers to the total number of records that our rule has triggered. Correct? So what is that? Total number of records that our rule has triggered means, we'll see. Our rule is if both the conditions are true, then it must be mammal. So this is my rule. How many records has really satisfied my rule? So how many records are really satisfying my rule? Yes, I have total how many records satisfying my rule? Warm blooded is equal to gives birth, yes, warm blooded. Then it is mammal, yes, the count is 1. Next, warm blooded, gives birth, yes, it's mammal, yes. Second, count is 2. Again you come to warm blooded, gives birth is equal to yes, mammals, yes, count is 3. Again warm blooded, gives birth is equal to no, I cannot take this. Next one, warm blooded, gives birth is equal to yes, it is mammals, yes, count is 4. Next again come here, warm blooded, gives birth is equal to yes, it is mammals, right? So total 5 records. All the 5 records that I have are clearly telling me that my rule, what I have written, is the correct rule, and I can now substitute the value of D in my formula, and my formula is saying coverage is equal to A divided by D. A is the left hand side of the rule where I got the count as 5, divided by D is the denominator, total number of records that has satisfied my given rule, and that is also 5. So 5 divided by 5 is equal to 1, correct? What is this saying? 5. Okay, I'm sorry, I missed one point there. I was telling about the accuracy there. Okay, coverage is A divided by D. D is the total number of records in the data set. Okay, right. So total number of records, I missed with the accuracy. I'm sorry. So coverage is what? Numerator remains the same, 5. 5 out of 15 records in my data set. My data set contains total how many? 15 records. 5 out of my 15 records actually is giving me the coverage value. So 5 divided by 15 is how much? It's 0.33, and that is a 33% coverage I'm getting. And now accuracy formula is what? Accuracy is A intersection Y divided by A. So what is this A intersection Y means? It is something like total number of records which my rule is satisfying divided by total number of records that my left hand side of the rule is satisfying. So already this denominator we have computed. 5 records are there which satisfies my left hand side, that is which satisfy my condition in the rule, that is body temperature is equal to warm blooded and gives birth is equal to yes. What about this numerator? Numerator is something like just now what I counted, the number of records that is satisfying my entire rule, that is left hand side and right hand side. What is that? If body temperature is equal to warm blooded and gives birth is equal to yes, then it is mammals. I just now counted and showed you, that is all 5 records out of 5 records is giving me the clear cut classification and it is satisfying my rule. And 5 divided by 5 is equal to 1. So the accuracy what we get there is 100% accuracy. So 100% accuracy, right? Okay, so this rule became a strong rule, right? Okay. This is how you calculate the accuracy and coverage, and this is how you write the rule, and this is how you do the classification based on the rules. Okay. Yes, and just we'll see the mutually exclusive and exhaustive rule. Okay, so what is this mutually exclusive rules? I'll just tell you. The rules what we have written here, say one such rule gives birth equal to yes and body temperature equal to warm blooded and then gives the mammals. So just see here, this is a rule and which is covered by 5 records here, covered by 5 records, correct? We have 5 records here which satisfies the given rule. And just see here, there are some other rules as well. Gives birth is equal to no aerial creature and aerial creature equal to yes. Gives birth is equal to no and aquatic creature is equal to yes. And all this, right? And is there any rule over here? Or we'll go with the other way. Is there any record here which is covered by 2 rules, what we have written? So is there any record which is covered by 2 rules? What is the meaning of that? If I have a rule, if I have a record warm blooded and gives birth is equal to yes. Yes, this record is covered by 1 rule, correct? And what is that rule? Our rule 3 is that gives birth is equal to yes and body temperature is equal to warm blooded, and this record is covered by that rule. Whether this record is covered by any other rule there? Other rule. So what are the other rules we have? Gives birth is equal to no and aerial creature is equal to yes. Gives birth is equal to no and aerial creature is equal to yes. Gives birth is equal to no and aerial creature is equal to yes. No, that is not covered. Again, gives birth is equal to no and aquatic creature is equal to yes. Gives birth is equal to no, I mean the same rule, I'm speaking about the same record, first record, okay? Gives birth is equal to yes and aquatic creature is equal to no. No, this is also not covered by rule 2. Again, rule 4, you see, gives birth is equal to no and aerial creature is equal to no. No, this no, impossible. First record, aquatic creature is equal to semi. Aquatic creature is equal to no. So this first record is satisfied by only 1 rule, and that is rule 3. So this record is not covered by any other rules, right? So your mutually exclusive is saying that a record should be covered by only 1 rule. It should, or in the other way, if we are saying the record should not be covered by 2 rules. A record should not be covered by 2 rules, right? So maximum only 1 rule. So that you call it as mutually exclusive rule. What is exhaustive rule? Exhaustive rule is something like you should not write a rule in such a way that doesn't cover any of the record. Or in another way, if I'm saying your record should be covered by at least 1 rule. I mean, it should be covered by 1 rule, or there should not be a record which is left out here, which is not covered by any of the rules. Okay, again I'll say you, exhaustive rule is something like no record should be left out in the data set which is not covered by any of the rule that you have written. So it's something like left alone, a record should not be left alone which doesn't satisfy any of the record. So that is exhaustive rule, right? Okay, so these are the 2 things we have. Okay, yeah, mutual exclusive and exhaustive rule set. These are the 3 rules what we have. Body temperature is equal to cold-blooded. So body temperature is equal to cold-blooded is equal to non-mammals. Yes, this is actually all the records which is satisfying this record, okay, satisfying this particular rule. You can just analyze this, okay? Again, I need not say this. Yes, and again we'll just go to the next method, that is direct method for rule extraction. Okay, we have two methods for extracting the rules. Okay, just now we said rule based, how you classify based on the rules. Now we'll see how to write the rule. So one method is direct method for rule extraction. So what is this direct method? We have an algorithm, sequential covering algorithm. As per this we extract the rule. So direct method is, here one example is given. Okay, let's see this algorithm and then the example as well. Okay, um, yes. Okay, so we call this algorithm as sequential covering algorithm. So as per this algorithm, it just says about the rule extraction. Okay, so how the rules are extracted one by one. So initially we start with the empty rule list. That means no rules are generated. Okay, so let's start generating the rule. So initially the list is empty. Okay, before that you just have your ordered set of classes. So what do you mean by ordered set of classes? Say like in example in for example in our vertebrate data set, we have their many classes, so widely classified, like mammals, fishes, birds, amphibians, etc. All these are different classes, the last column in the data set. Or else I can take it as mammals and non-mammals as two classes. Okay, so in that case I have y1 and y2. So or let me take those classes first. Okay, list of classes, and then we have the set of attribute value pairs. Attribute in the sense like body temperature, aquatic creature, aerial creature, all those are the attribute sets, right? Okay, so let's start now. I have the list, initial rule list, which is empty. So let me start with the iteration now. Okay, yes, so here what we are supposed to do is, okay, so we will use one function called learn one rule. Okay, so what is this learn one rule? I'll just tell you. Okay, this is something like finding the best rule for this particular class y. Okay, so what is that best rule? I'll just tell you one example. Yeah, in this, say this here, what you can see is the collection of various records, I can say. So what is this records here? I have a data set where you have many records. In our vertebrate data set, do you remember we had 15 records, 15 rows in the table data set. So here you can see the collection of negatives and positives. So here negative and positive indicates the classes. Okay, so here I have positive class and negative class only. So let me take this positive as mammals and negative as non-mammals. Okay, something like that. And you can see many plus and minus. What is it indicating? There are 1 2 3 4 5 6 plus 7, 8, 9, 10, 11, 12, 13 and 14. 14 plus classes. It indicates that there are 14 positive or 14 records which belongs to this positive class. Rest of the records here are all belonging to negative class, correct? Okay, so here let me concentrate only on one class now, and that class is positive class. So what is that I'm trying to do? Let me generate the rules, or let me write the rules for only this positive classes to generate or to classify positive class. Okay, so here for this positive class I'm going to write one rule. Okay, for example, what is the rule? Like something like body temperature is equal to warm-blooded and gives birth is equal to yes, which if both are true, then the class group is mammals. So let me take that particular rule. So I have written that rule. Now that rule you compare that rule, or else you cross verify that rule with the given data set. If in the given data set that rule covers many records, if that rule covers many records which belongs to this mammal class group, say recall your vertebrate data set, I'm going to write a rule, say body temperature is equal to warm-blooded and gives birth is equal to yes, which gives mammals, right? So if that rule covers many examples, many rules in your if that rule covers many records in your data set, maximum records, then that particular rule you add to your list. that means that rule is a strong rule, right? So you just see here, plus I have written a rule and that has covered 1, 2, 3, 4, 5, 6. For example, this is just assumption, okay? Total 6 classes, and here as I said, I'm focusing only on plus class. So that plus class, let me take it as mammals class, and my rule has covered total 6 records in my data set which belongs to this mammals class, right? So here the 6 records. So here, if your rule covers maximum of plus class, positive class, and very less or almost no negative class, if it covers no negative class or one at least, or maybe minimum 1 or 2 negative classes, then such a rule you are going to generate, or you are going to add that rule to your list. Okay, so here you can see this rule has completely covered only and only positive classes and no negative classes it has covered, right? So you can I call this rule as a strong rule? Yes, and I'm going to consider that as rule as a strong rule, and that rule, whatever you have written, that you're going to add into this list. Initially the list was empty, now that rule you're going to add it to your empty list. Okay, right? So now after adding the rule, now you just see here that became empty. That means what? Those records which has clearly satisfied, or that records which are covered by this rule, we are going to eliminate those records from the data set. Anymore no touching those records. Those records are eliminated from the data set. Okay, so you can see those records are empty, those plus are removed now, correct? Now after that, after removing those records, you are left out with these negative records and few of the positive records, correct? Okay, so now you're going to write the next rule, that is R2. R1 is already added to your rule list. Now your list contains one rule, and those records which are covered by that rule R1 are already removed. Now remaining records, you see, now I'm going to write a next rule, R2, and see that R2 covers 4 positive classes, or 4 records belonging to positive class, and there is only one record that belongs to negative class. So now tell me, can I add this rule to the list? Yes, as I already said, the rule should cover almost all positive classes, and here no negative classes should be covered, or 1 or 2 negative classes also if it covers, not a problem. I can consider that rule. So 1 negative it has covered, that is not a problem. I'm going to add that, I'm going to consider that particular rule, and that rule is going to again I'm going to add that into the list. Now my rule list contains how many rules? Total 2 rules, R1 and R2, and you see here that is empty. That means what? All these records which are covered by R2 are removed. Okay, removed. So this process you're going to continue. So you can see in the algorithm we have written learn one rule is best rule you're going to extract, and that extracted rule, what you're going to extract, that should be covering maximum number of records, positive records, okay, and very less or almost no negative records. So such records, whatever is satisfied by the rule, should be removed, and that rule what you have written or generated should be added into the list. Okay, so that is done in a loop, and that loop is going to be that you're going to iterate there until you reach until almost all the records are completed. Okay, right? And if suppose you are finally your finally see, you're going to add one rule called something called as a default rule. Okay, so what is that default rule? Means if no rule is satisfying, or if any record is left out, which is not satisfied by any of the rule, then this rule you can take. What is this rule saying? You just see LHS is empty. That means what? No condition you're specifying in the left hand side, but the right hand side is saying that it is belonging to one particular class, say Y, generally one class Y. So here that means what? If the record is not covered by any of the rule, such a record, left out record, can be covered by this default rule, where there is no condition specified, correct? Okay, so that default rule you're going to add again to the list. Okay, right. So this is the sequential covering algorithm, and this you call it as direct method for rule extraction, wherein you start with the rule and then see how many positive records are added, and then those rule which covers maximum of positive records, you add that rule into the list, and those records which are covered by the rule should be removed. Okay, so this is the direct method for rule extraction. Now we have yeah, these are all the rule going methods and all that. So you have some techniques here to find out whether the rule generated is accurate or not. Okay, so you have two metrics, Laplace and M estimate. So you will understand this if you read. So it is simple. Okay, all these are simple. Okay, yeah. Okay, yeah. Next method what you have is indirect method for rule extraction. So what is this indirect method? You just see here, it is simple again. You start with the tree structure here. Indirect method is first you write the tree structure. Remember your Hunt's algorithm.